All right. Welcome back, everybody. This is 11.3b. I think the worksheet says 11.3a. Yeah, I'm a scrub. Let's do the first one together. Hopefully you saw that we can find the cosine theta with u dot v. It comes from law of cosines. Uh, in this case, I don't have a u and a v. I have a v and a b, so we'll just do v dot b. I've got 1 times 6 plus 2 times -8. That is 6 minus 16 is -10. Magnitude of v, square root of 1 squared plus 2 squared is square root of 5. Magnitude of b is 6 squared plus -8 squared. That is square root of 100, or 10. So now we'll fill out what cosine theta is. Cosine theta, and it's worth writing down the full equation until you have it completely memorized. Here I'm doing b dot b over magnitude of v, magnitude of b, which is -10 over square root of 5 times 10. And so cosine theta will be -1 over root 5. Since that's not what our final answer is, you really don't need to rationalize because you're going to be doing this operation in a calculator anyways. So theta should be cosine inverse -1 over root 5. I strongly recommend putting that shit on a test. If you get asked for an angle, that's at least 100% correct. Now, you should be doing the calculator work also. Where's my calculator? Cosine inverse. And I'm going to write both radians and degrees. I'll do radians first. -1 divided by square root of 5. So theta equals 2.034443936 radians. And you don't even need to write the words radians, but I did. Or in degrees, 116 point, I don't know, 1 decimal seems good here. If you do radians, you should probably do at least like maybe 4 decimal places for radians. Decimal or degrees, you really only need 1, and that's because a full circle in radians is a little over 6, but a full circle in degrees is 360. So like me saying 116.6 degrees or 116.7 degrees, even adding more decimals, I'm not really helping me picture where it is on the circle, right? I'm not getting any more accurate. Now, if you're doing something where you need more accuracy for whatever career you're doing, obviously do the accuracy you need. But for me, I at least do 3 or like do 4 degrees or 4 decimal places if you're doing radians at least. Then that's it. That's fine. Found the angle. If you were to sketch it just to see what it looks like, I need a lot of in the negative direction. Let's change this some. Let's do this. 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. And we're saying like that angle is about 116 degrees, 116.6, which seems reasonable. If I did like made it like perpendicular to the long one, that looks like that's about 90 degrees. So like having it be a little bit bigger seems reasonable. I just did the sketch to like help you visualize what's going on. You don't need to do it on the other ones. Go ahead and work on B and C, and then we'll do it together. While you're doing working and studying stuff, not just for my class, but any class at home, if you get stuck on something, don't look it up right away. We were talking about this earlier. Don't like look it up. Try to work through it and figure it out. Try different things. Because when you jump straight to AI or Google, all you're doing is crippling yourself, literally crippling your thinking ability, your critical thinking. You're only learning how to solve problems that look identical to the ones you're looking up. You're not learning how to think through shit. So like, I know it's easy to fucking like want to speed up things and get homework done faster, but you're ultimately screwing yourself. And like, if you want to be an engineer or something like that, you need to have good reasoning skills, good thinking skills. Don't cripple yourself. There's nothing wrong with looking it up later on. Like, try to figure it out. If you're stuck after 20 or 30 minutes, then look it up, or ask a friend how they started. The less you look up, don't if you look up how to do something, don't watch the full fucking solution. Look how to see how they started and see if you can proceed from where they started on your own. That way you're at least like minimizing the amount of help you get. All right. We'll go on work on this. Let's see. We got V dot B on this one. That looks like 3. Magnitude of V, what is that? That is square root of -7 squared plus 3 squared. That's 49, and 9 is square root of 58. Magnitude of B is 1. Another way to write 0, 1 is the J vector. We'll talk about IJK in a second. I'm sure I've done it before, but it's going to come in handy when we do directional angles. We're hitting cosine theta. Cosine theta is V dot B, which is 3. Oh, wait, I want to write it down. Practice writing it down. Three over square root of 58 times 1. So theta is going to equal cosine inverse of 3 over square root of 58. Three. And I want it to be positive. There we go. So in degrees, it's 66.8 degrees. Radians, 1.1659 to 4 decimal places. Right? Okay, good. It's always good to, if you get something else at some point, we should talk about it. One of us has done it wrong, and it might be me. As amazing as I think I am, I'm not flawless. Don't tell anybody I said that, though. We got 1 times 8 plus negative or minus 3 times -2 plus 7 times -2 is 8 plus 6 minus 14 is 0. I don't really need to do the rest, do I? Cosine theta equals 0. Does it matter what magnitude of V is or magnitude of B? Not really. I mean, 0 divided by it is going to be still 0. So theta is cosine inverse of 0, which is what? It's pi over 2 or 90 degrees. So if the dot product equals 0, what can we conclude without any further effort? The angle is pi over 2, or the vectors are perpendicular or orthogonal, right? Vectors are orthogonal. It's very important to note that this is because cosine theta equals 0. Students sometimes forget and do u dot v equals 0, and they start lining up other things with the trig to go with it. Like, for example, like cosine of 0 equals 1. That says theta, 0. And cosine of like pi is -1. That doesn't mean, and cosine of 0 would mean they're parallel, right? They're actually pointing in the same direction. V and B are in the same direction. -1 means they're parallel but opposite. So maybe V is going that way and B is going that way. And they could be different lengths. They're just pointing in opposite directions. This doesn't mean you can just go with the dot product and assume parallel. Because it only worked on the equaling 0, because 0 divided by anything is still 0. Here, u dot v equaling 1, we still got to divide by the magnitude of u and the magnitude of v, and it's probably not 1 anymore. And so, like, don't just assume that. And it seems like a weird thing for me to say, like bring up, but I've had students get in their head and they know like the angles, they know 0, 1, and -1 applies to perpendicular or parallel, and they immediately jump to that being the dot product, not just the angle. And so I've had students just do the dot product and jump to like saying these are parallel, and that's not true. You didn't finish the work. You applied the rules of cosine to the dot product, and it's not enough. So don't make that mistake. All right, directional angles. Previously, we had V equaled magnitude of V cosine theta sine theta. That was in 2D. What's the 3D version of this? Call that vector V. Well, if we look at what we were doing with the 2D version, we were finding the component in the x direction and the component in the y direction. That ended up being magnitude of V cosine theta there, magnitude of V sine theta there by doing some trigonometry, or we could have gotten this by doing the projection and knowing that the dot product produces cosine. Something similar happens here. We have an angle, but now like on the 2D triangle, it's the same angle for both. On the 3D triangle, it's making different angles with each axis. Again, we're like, this is doing an angle with that axis, an angle with that axis. But we're going to use like alpha for the x-axis, beta for the y-axis, Books like to use gamma or something like that. I can't fucking do a good gamma symbol. I'm doing phi. So let's focus on real quick on just doing at a single component. Let's make that narrower. We're going to take the v vector and we're going to use that cosine theta we just did. But here it'll be cosine alpha. That didn't show up very well. Let's use a different color that's a little brighter. There we go. So I've got here cosine alpha equals v dotted with x-axis all over magnitude of v, magnitude of x-axis, which sounds weird. We don't, what is the x-axis? It's really like x1, 0, 0 for along the x-axis. So rather than picking just any x, let's go with 1, 1, 0, 0, or I. So now this turns into v dotted with I over the magnitude of v, magnitude of I. What is the magnitude of I, though? 1. If I've got V being V1, V2, V3, and I dot it with I, which is 1, 0, 0, V dotted with I, it just pulls out V1. You guys see that? Same thing's going to apply with the other ones. V dotted with J is going to pull out V2. V dotted with K is going to pull out V3. So that vector, the unit vector along X is I hat, unit vector along Y is J hat, and the unit vector along Z is K hat. So like the dot product is really just pulling out the component in the V, that component in V. And I do that with the other angles. You'll notice the same thing happens with the other angles. Cosine beta, V dotted with Y axis. I'm doing now the orange line with, say, the blue line. V dotted with Y axis. We're doing magnitude of V, magnitude of Y. But that's just turning into V dotted with J. And we end up with the same thing. Cosine alpha ends up being V1 over magnitude of V. Cosine of beta is V2 over magnitude of V. And cosine of phi is V3 over magnitude of V. Maybe I'll change that to be a different color. Red it is. I could write out that whole same thing with V dot K and do the same thing, but I hope you guys see that like it translates pretty well. Which means like I can write V as magnitude of V This is effectively what I'm doing. V1 over magnitude of V, V2 over magnitude of V. V3 over magnitude of V. Like I just multiply top and bottom by magnitude of V and I just move that in, which means V can be written as magnitude of V cosine alpha, cosine beta, cosine phi. The directional angles all fall out of doing this dot product with and doing the cosine theta version of dot product. So even if you don't remember that, as long as you remember cosine theta and are able to reason this stuff out, that's why it's like practice your reasoning skills, you can rederive this thing. I've seen students rederive spherical coordinates on a fucking test. Like the formulas that contrive it. I'm like, God damn, they drew out the pictures of the triangles on a test? That's not a lot of time. He did. I was like, he didn't remember them, so he drew them out. That kid got he was in high school too, taking Calc 3. Fun, crazy. All right, so we need to do that here. So looks like, what do I need the most? What's going to help me solve this problem? We need the magnitude, right? You really should put the shit in parentheses. I guarantee you, if you don't put in parentheses and have that minus in there, you're going to get distracted and you're going to fucking treat it as a minus. But when you square a minus, it turns positive. And if you don't put the parentheses, there's a chance you'll forget. We got square root of 9 plus 4 plus 36. 36 and 4 is 40. 40 plus 9 is 49. Square root of 49 is 7. Which means cosine alpha is V1 over the magnitude, which is 3 over 7. So alpha will be cosine inverse of that. Cosine beta, negative 2 over 7. And cosine phi is negative 6 over 7. I'm just going to do the degree version here to keep room in there. I'm getting 64.6 degrees. 106.6 degrees for beta. And looks like 100, if I round correctly to one decimal place, 149.0. Like I know when I look at just this picture over here, when I look at this, it just confuses the shit out of me looking at it individually. If I start looking at it and thinking about doing it as a dot product, then it fucking makes sense. Like in my head, and you guys might struggle with the same thing. I'll be like, is alpha, like, is it really going up to V or is it like a projection onto like a plane or something. No, it is literally the vector dotted with the other vector. It falls out from doing the dot product with and having the cosine theta version. And so that's the way I go, okay, no, it's not in a plane. It's making it just two vectors. We're finding the angle between them. All right. I don't see a lot of people still writing. Let's do this one together, and you guys are going to coach me through it. I'll do the setup, reading what it says. It says, find the shortest distance between P and a line AB. So maybe I'll highlight this as what I need to do. And it looks like it's 2D, so I'm going to draw a 2D sketch. And it looks like I have a point at 2, -3. That's A. And 5, 1 is up here, and that's B. And the line is doing that. So that's my line there. And I got a point P at 1, 0. That's what we have. So graphically, how should I draw the shortest distance between P and that line? Line perpendicular to AB that goes through P. But that seems reasonable to me. So if we do it perpendicular like that, I'm going to do this. Watch how it swings. If I go left, the line is getting longer as I go that way. The line gets longer if I go that way, and the line gets longer when I'm here. It's pretty short, but the line gets longer when I go that way. So I'm making it so it's perpendicular. Probably is going to produce the shortest thing, right? That track. All right, now what can we do? Clearly it's in this section for a reason. So like dot product is probably going to come up. What can I, but dot product of what? And how can I use this? Any ideas? You know what? I'm going to draw that line thicker because that's the line we want. That's the line we want.
You want it to be like orthogonal? Or are we hoping like the dot product is 0?
So that's one way we can look at it. So like, I don't know. Let's call this point, I don't know. You know what? Let's relabel B, D. I'm going to call this point D instead of B. Because we were doing V and B for a lot of shit. And so like, I don't want to have B anywhere in there. Let's call this point like, I don't know, F. So if I could show that like maybe AD dotted with PF equals 0, that means the cosine of the angle is 0, and we got orthogonal, right? I have information. I can figure out AD. What is AD? Well, AD is going to be like, if we look at it, it's kind of like the same way you do distance formula. You're doing subtraction of coordinates to get like a distance. we're going to do the same subtraction of coordinates here. I'll say like D1 minus A1. This is just to give you an idea, like help you track what's going on here. D2 minus A2 does something similar. We're finding the distance and distance there, because that's what it's based off. That's like if I call that A and B or A and D, it's doing shit like that. But that's the distance formula. So this is going to apply over to this one. We've got D1 minus A1, 5 minus 2, and then 1 minus -3. I'm getting AD equals 3 comma 4. That seems pretty important. I'm going to highlight some bitch. That seems important. Okay, can I get PF? What's F? We don't have F, do we? So, like, it looks like it's at 3, -2, but if it's at 3, -1.9, we're fucked. So, like, don't, like, guess that it's perfectly aligned with integer values. We don't have F, so, like, so PF is off the table. So our first attempt didn't work. What else could we do? That was a good try. It was a good, always try something. What else might work? Dot product requires two vectors, right? This is a dot product vector. PF isn't a vector we can use, so what other things could we use for vectors here? AD is one of them. What else could we use for a vector? AP. All right. So let's sketch out AP. I don't know. Let's go purple. Maybe I'll make it a little thicker because it's a little hard to see that thin ass line. And what is AP? AP will be set up the same way. It's P2 minus P1, 0 minus A is 2, and then we do, nope, that's 1 minus 2, sorry, my bad. And then 0 minus -3, looks like -1, 3. Yeah, that looks about right. If I look at it going like this, it's going over 1 and then up 3. All right, what can I do with AP and AD? Let's grab this. Having it look like that is a little hard. So I'm going to do this, and that way AD is like flat and a little bit easier to see. So if I have AP and AD, let's draw a thick line on AD. AD is doing, I didn't make it thick. AD is doing that. What do you mean? Hmm? We could do vector addition if we had this portion right here. If we could get that portion right there, we could do vector addition. We could say the green line, green plus blue equals purple. That seems reasonable now, doesn't it? Does projection sound good? Projection sounds good. What are we projecting here, though? AP onto AD. Like if I put the sun up top, and it shines down, AF looks like it is the projection of AP onto AD, right? And AF is the green line here. So we've got AF plus PF equals AP by vector addition. That's what Andrew said. And we want PF, right? No, what do we actually want here? Not we want the shortest distance back to the original question. Shortest distance between P and AD is a long PF, but PF is a vector. And if we want what? Magnitude. So we want our goal is magnitude of PF. That's our goal here. Excellent. All right. So it looks like if we do some vector subtraction there, AP minus AF, and we just found a way to calculate AF. We're almost there. We already have AP. AP is right here, and that's what's right there. Now we just need AF. So we need to do the projection. So I need AP dotted with AD over the magnitude of AP, magnitude of AD. Nope, that's not the right formula. That's fucking cosine theta. We need B dot B, we need AF or AD, magnitude of AD squared. And then we multiply it by the direction of AD. Because it was like if we did B and a B down here, it was V dot B over magnitude of B squared in the direction of B, where B is AD. All right, so what is the magnitude of AD? Magnitude of AD, that's our 3, 4, right? So we got the square root of 3 squared plus 4 squared, and then we're squaring that. And then we're going in the direction of AD, which is 3, 4. This is definitely going to be easier in parts here, right? I got -1 times 3 plus 3 times 4 all over square root of 25 squared times 3, 4. -3 plus 12 is 9. We got 9 over 25, 3, 4, which is 27 over 25, 36 over 25. And that was AF, our projection. So we wanted PF, and we had PF was AP minus AF. AP we have, AP was -1, 3. And we're subtracting AF, which is 27 over 25, 36 over 25. This might be easier if I multiply this first one by 25 over 25. So I have -25 over 25, 75 over 25. And then that again. I have -52 over 25. 75 minus 36 is 39. So that's PF. All right, now we want the magnitude of that, right? What is that top? 52 squared plus 39 squared. And then square root of answer. 65 on top. 65 is 13 times 5. 25 is 5 times 5. This reduces to 13 over 5. 2 3/5 or 2.6. Not bad. Not the easiest thing to figure out, right? You gotta like it's learning how to use the tools that you know how to use and figuring out how you can apply them here. It did help to know that we were doing dot product. Like that kind of like we had a hint here. The section we're in, we were doing dot product, so that was a hint of what we're doing. But like hopefully reasoning it out once as a class, if you see something like this in the future, you might be able to figure this out when you're doing vector stuff. There are other ways to do it, but like vectors just made it not too bad. And it's noon. If you've got other classes, have a good day.